Today we'll be doing the integral from minus infinity to infinity of the sine of 1 over x squared dx. And to start off, we could rewrite the integral. Since the integrand is even, we have twice the integral from 0 to infinity, the sine of 1 over x squared dx. And from here we will use integration by parts. So we're going to let u equal the sine of 1 over x squared, which means that du equals negative 2 over x cubed cosine of 1 over x squared dx. And that means that dv equals dx, and that also means that v equals x. So we're going to have a x sine of 1 over x squared from 0 to infinity, and minus the integral from 0 to infinity of v du, so minus 2 over x cubed cosine of 1 over x squared dx. And in the limit, this will end up being 0. These will turn into a positive, and we have 2 times 2, which is 4. So we have 4 times the integral from 0 to infinity of x over x cubed is 1 over x squared cosine of 1 over x squared dx. And we'll make yet again another substitution. We're going to let y equal 1 over x squared, which means that x squared equals 1 over y, but that also means that x equals 1 over y to the 1/2, which is y to the negative 1/2. So differentiating that, we have dx equals negative 1/2 y to the negative 3/2 dy. The bounds of integration, y1 is 1 over 0, which is approaching positive infinity. Y2 will be 1 over infinity, which is approaching 0. So we're going to have 4, and then the integral from infinity to 0 of y cosine of y and dx is negative 1/2 y raised to the negative 3/2 times dy. And we can rewrite this as 4 over 2, the integral from 0 to infinity, y over raised to the 2 over 2 power times y to the negative 3/2 times the cosine of y dy. 4 over 2 is 2. The integral from 0 to infinity, multiplying the y's, we have a y to the negative 1/2 times the cosine of y dy. So we have twice the integral from 0 to infinity, the cosine of y over the square root of y dy. And we're going to yet again make another substitution. We're going to let z equal the square root of y, which means that z squared equals y. That means that dy equals 2z dz. The bounds of integration will not change. So we're going to have twice the integral from 0 to infinity cosine of z squared over z, and dy is 2z dz. But the z's cancel, and we have twice times twice the integral from 0 to infinity of the cosine of z squared dz. But since the integrand is even, we can rewrite this as twice the integral from negative infinity to infinity of the cosine of z squared dz. And we'll write this as twice the real part of the integral from negative infinity to infinity of e to the I z squared dz. And now we'll use the fact that the integral from negative infinity to infinity of e to the negative ax squared dx is equal to the square root of pi over the square root of a. So if we solve for a, we have negative a equals I, which means that a equals negative I. So we're going to have twice the real part of the square root of pi divided by the square root of negative I. So we're going to have 2 times the square root of pi, and then the real part of 1 over negative I to the 1/2, which is twice the square root of pi, and the real part of negative I to the negative 1/2 power. So now from here, we'll let u equal negative I to the negative 1/2. Taking the natural log on both sides, we have the natural log of u is the natural log of negative I to the negative 1/2, which is negative 1/2 times the natural log of negative I, which is negative 1/2. The natural log of negative I is negative I pi over 2. So we have the natural log of u is I pi over 4. Taking e on both sides, we have that u equals e to the I pi over 4. But that's just the square root of 2 over 2 plus I times the square root of 2 over 2, which is also equal to negative I to the negative 1/2. So we're left with 2 times the square root of pi, the real part of the square root of 2 over 2 plus I times the square root of 2 over 2. So we have 2 times the square root of pi. The real part of this complex number is the square root of 2 over 2. But as you can see, the 2's divide to 1, and we're left with the square root of 2 pi. So now we can say that, therefore, the integral from minus infinity to infinity of the sine of 1 over x squared dx equals the square root of 2 pi. And so this is the final result to the integral. Thank you very much for watching.